Welcome 8th grade, adding and subtracting with unlike denominators. I'm going to kind of buzz because I think you guys got this. All right, if you don't, that'll be the time where you can stop me and be like, Mr. Palm, we need to take some time. All right, so add or subtract. Now, we need to think about these. This sign is not helpful. This positive, this negative. Signs are the opposite. Oh, opposite. Subtract and keep the sign of the bigger. So it would be 1 and 1/5. All right. This one positive. This one, if we look at the sign in front, negative. Same denominators is nice. One positive, one negative. So opposites, we subtract and keep the sign of the bigger. It would be 1 and 4/12. So they're going to reduce that to 1 and 1/3. Okay. This one, decimal of 65, that's positive. This one has a negative with it. They're opposite. So you subtract and keep the sign of the bigger, which would be 5 and 3/10. All right. This one, positive. This one, negative. We look at the sign in front of it. So we subtract, and that would be 2 and 5/10. We get our answer. Now, problem of the day. Well done. 8 and 24. To learn to add and subtract fractions with unlike denominators. Nothing real terribly hard. That's why we're going to go ahead and go through 2 of them. Sorry the numbers are all messed up. We're going to solve this problem with unlike denominators. Find a common denominator by multiplying one denominator by the other. All right? Or find the common denominator using the LCD. There are 2 different methods. Either one is fine with me. I would say the LCD is going to be your least work. So what they said is I can either say, 8 over 8, and I get 16 over 56. And this one, 7 over 7, and I get 7 over 56. And I remember that they're adding. So 23 over 56 is what my answer is. Now, this one, we just took the denominators and multiplied them times the other number and got our answer. All right? Sometimes that's not always the easiest thing to do. This time, it is. Okay? So we do that multiplication and we get our answer. Here, when we look at these, now we're only going to look at the fraction portion. All right? Because I see that 1 minus 1 is going to be 0, so it's really like those aren't even there. So now, I could take I could take this one times 6 over 6, and I could get 48 on the bottom, 30 on the top. Important, I could take 8 over 8. By this one, I get 48 on the bottom, and I get 8 on the top. I do my subtraction, so that would be negative 22 over 48, and I know that'll reduce down to, divide by 11, divide by, no, it doesn't divide by 11, so divide by 2, divide by 2, I get negative 11 over 24, and I've got my answer. I took the denominator, and I just made it into a fancy 1. I multiplied it. Took my denominator, made it into a fancy 1, and I multiplied it. I got these, did the subtraction, then I reduced. My suggestion, instead of doing all of that work, you can always go back and pause it at this point, is use the LCD. You guys are pretty good with that. I'm not asking you to write everything out. I see that 8 will go into 24, and so will 6. So if I do 3 over 3 here, that gives me 15 and 24. And I see 6 to make it 24. I need to go by 4, so I do the same thing to the top. Both 3 over 3 and 4 over 4 are fancy 1s. That would be 4 over 24. It's still subtraction. 1's positive, 1's negative. Subtract. 11. Keep the sign of the bigger. 15 is bigger, so it's negative. Then we have 24. One step. And my multiplication was easier. If you can find the LCD, it makes your life easier. If you cannot, well, you can do it the long, hard way, and that's fine, but I really would say method 2 is going to be a lot easier. Now notice, they changed everything to a mixed number first, or an improper fraction first. I chose not to because of what I saw. Oh, 1 minus 1 is going to be 0. They'll still get the same answer. All right? 28 minus 39, which is negative 11 over 24. Okay? Here, we can take the denominator over the denominator. We get 15 over 24. We can take the denominator over the denominator. We get 8 over 24. We add those together, 15 and 8. That makes for 23 over 24. And it works out nicely. The 24 is actually ended up being the least common denominator, so it works very nice in that situation. All right, it doesn't always work out nice like that, but it did in this situation. So watch what they do. They find that, they took the 8s over here, then they took the 3s over there, and then we've got our problem that worked out just like we had it. Now, I like to look at just the fractions, and remember, 2 is going to be the whole number in front of them, okay? Method 2, we want to find the least common denominator. What's the smallest thing they'll both go into? I know they'll both go into 24, but I think I can do better. Maybe you see that, like I do, they both can go into 12. So if I do this one by 3 over 3, I get 9 twelfths. This side, if I do 2 over 2, I get 2 twelfths. And I know that there's that whole number 2 in front. 2 twelfths plus 9 twelfths is 11 twelfths. Don't forget your whole number, 2 and 11 twelfths. There is our answer. All right? They are going to switch it to an improper fraction first. I don't think that's necesito, but if you do, go ahead. Notice they changed it to the improper fraction. They'll still get the same answer. It's just you're going to have one more step in there. 26 over 12 plus 9 twelfths equals 35 over 12. Then we turn it around and we go 2 and 11 twelfths. All right. Evaluate. It's not hard. Literally, they say put that there. That's all they're doing. 5 sixths minus 4 fifths. All right, we're ready to do some work. Denominators are not the same. Shucky darns. So, in this situation, I know that they'll both go into 30. So, if I take this side times 6 over 6, because that makes the bottom here 30. 6 times 5 is 30. Yay! All right, 6 times 4 is 24. All right. Over here, I do a different number because I want 6 to be 30. So I do 5 over 5, and I get 25 over 20, or over 30, excuse me. 1/30 is my answer. I've got what I needed to. Using that LCD, it is a least common denominator for a reason. You guys have done good with fractions. We took lots of extra time last year, so hopefully it pays off this year. All right? They got the same response I did. Really, literally all they're saying is plug this in here. But don't forget about the trick. 5 ninths minus negative 7 twelfths. You need to remember, minus a negative is the same as turning it into an addition problem. All right, so this one, we could take this times 9 over 9. We could take this 12 over 12. But in the back of my head, I'm thinking, 36 is a number they both go into. So 3 over 3, that gets this to be 36, the 12 to be 36. So that's 36 on the bottom for the denominator. 21 on the top for the numerator. I know it's going to be addition because I saw minus and negative. That's addition. This side, I'm going to use, 4 over 4. That's 20 over 36. When I add these together, I get 41 over 36. Please don't forget how to turn these. 41 is beneath the fraction. That's the numerator. 36 is on the outside. We go till we get to the decimal. Okay, that's 1. There's 36. All right, that's 5. We know that the 1, that's our whole number. The 5, that's the numerator. And the 36, just like before, that stays the denominator. 1 and 5 36ths. All right? They got our same numbers here. They got, feathers. They got 41 over 36, which is way down here. And they got 1 and 5 36ths. You guys are getting pretty good at these, I'm hoping, by now. So 2 dancers are making a necklace from ribbon for their costumes. They need pieces measuring 13 3/4 inches and 12 7/8 inches. How much ribbon will be left over after the pieces are cut from 36-inch length? So I need to know how much they're making together. So I get 13 3/4 plus 12 7/8. Now we could make them improper fractions and deal with huge numbers, or I can think, I know if I turn this into 8s. 8 is that. So 6 8s and 7 8s. And then I add these two. Okay? 6 8s plus 7 8s is 13 8s, or 1 and 3/8. Okay, that's very good. That takes care of the fraction part of it. But what I got to remember is I have a 13 up here I didn't use. So there was 13 inches plus 12 inches plus, this was the fraction part, so plus 1 and 3/8. When I do that, 13 plus 12 is 25, plus 1 is 26. And we just keep that fraction with it, 26 and 3/8. All right. That works very good. Hey, I've got how much ribbon they use. Well, this is how much ribbon they use, 26 and 3/8. I want to know how much is left out of 36. So we have to do some subtraction. We have 36, and it's minus 26 and 3/8. That's not math we're used to doing, but if we use a little bit of thinking, hey, couldn't I say 35? And I take that 1 that I took there and I make it 8 over 8? Because isn't 8 over 8 1? Oh, it's like I'm borrowing. I say, this is going to become 5, and this is 8. I'm dividing this extra 1 into 8 out of 8 pieces. We always choose 8, or not always, we choose 8 in this situation because when I subtract 26 and 3/8, I have common denominators. That's a good thing. So 8 8s minus 3/8, 5 8s. 35 minus 26, 9. There are 9 and 5/8 inches left of the ribbon. So we add it together to get the total, then we subtract it away. And in the meantime, we borrowed and turned a 1 into 8 over 8, because that's just a fancy 1 anyway, right? All right, let me erase this real quick, and then we will work on showing you what they did in their many and multiple steps. All right? All right. So they did repeated subtraction. They subtracted, they turned everything into mixed numbers. Do you see how big these numbers are? I think my way is easier, but you have a right to know their way. 9 3/8 is what we got down there, just like them. Okay? Fred and Jose are building a treehouse. They need to cut a 6 3/4 foot piece of wood and a 4 5/12 piece of wood from a 12-foot board. Well, how much of the board will be left? Well, if I have 6 3/4 and 4 5/12, I've got to figure out how much total I need. Oh, that's 12. 4 will go into 12. If I take this times 3 over 3, I get 9 twelfths. Hey, plus 5 twelfths. Let's just work on the fraction part. Okay, that makes 14 over 12, or 1 2/12. I'd rather say 1 1/6. That would make it simple as 4. Then we got to remember 6, that whole number, plus 4, the other whole number. All right. Then plus the 1 1/6. 6 plus 4 is 10, plus 1 is 11 1/6. That's how much wood they're going to be using. That's how many feet they're going to be using. I need to know what's left out of 12. So aren't I going to do subtraction? 12 minus 11 1/6. Okay. Time to borrow. I don't want that to be 12 anymore. I want it to be 11, and I'm going to take that 1 that I borrowed, and I'm going to make it 6 over 6. Hopefully you're saying, I know why you made it 6 over 6. Because that means you were paying attention. 6 over 6, because they have the same denominator now. So 11 minus 11 is 0. Oh, I don't have to write 0 down. 6 minus 1/6, that's 5 over 6. 5/6 of a foot is all they have left out of their board that was 12 feet long. They are going to turn it into mixed numbers and do long and tedious math. Hopefully you see the ease with which that happened. Okay? So they turn them all into mixed numbers, improper fractions. All right, they get a common denominator for all of them. They did that. 10/12 or 5/6. Hey, we did get the same answer. Hopefully you're ready. Thank you, guys.